So hello, my colleagues, and I hope everyone is doing well and following all the rules about washing your hands and wearing masks and being safe, okay? So I want to pick up here at 5.2 in our textbook, single amounts, and we're going to talk about the future and present value of a single amount of money, and we're going to simply define that as someone who gave you just, either you gave someone or they gave you a one-time shot of money, okay? So the future value of a single amount is pretty much the most basic type. So, and they ask a nice simple question here. So if someone gave you, or whatever, $500 right now, and you put it into an account and it was paying 2%, which I guess in these days would be good, right? Interest, how much would you have in 10 years? And that's the definition of a single amount of money problem, right? Future value. Okay? So this is the value on some date in the future, right? And a lot of people, you can look at this as a present value too, which we will do eventually, all right? So this future value is going to depend on how long it's in the bank, how much someone gives you, and the interest rate. 3 inputs, right? All right, so you'll collect compound interest in some banks, right? You put it in and you'll get 2% this year, and then you'll get 2% on the 2% next year, and that's called compound interest. The money's compounding, right? But of course, you'll do much better in the stock market all the time, but that's my own personal opinion. All right, so it accumulates more and more over time. And the principal definition is what you originally put in the bank, right? Okay, so let's look at a simple calculation here. And Fred Marino, he puts $100 in an account paying 8% interest, compounded annually. So the interest is going to just be added to the $100 in the bank and not taken out. After 1 year, he will have $108 in the account. That's just the initial principal of $100 plus the 8%. So that's one time. See, this is 1 year, right? So you can see how simple it is. You take $100 and multiply 1 plus 8%. Don't forget to change that to a decimal, all right? All right, so now the second year goes by. You see it says here after 2 years. So now you got your 108 and you're going to put it here. And now you're going to get 8% again. And you'll now have 116.64. Now this is much, a little higher than you would have if you didn't get compounded. You would only have 116, right? So you get an extra 64 cents, right? Because of the compounding. But don't laugh at that, because if, let's say you put 100 million in the bank, right? Let's say you put 100 million in the bank, and that would be an extra, what, $640,000, right? So that's a lot of money. So here's how it's done after 2 years. All right, so let's just get this quick video and then I'll show you the equation. All right, let's go through this quick video so everyone sees it.
In this example, we look at one of the most important and useful ideas in finance, the concept of future value. The future value of a dollar tells us how much a dollar will grow over time, given that it earns a particular interest rate. The mathematics of future value is relatively simple, and nearly everyone can benefit from an understanding of future value, because it helps people determine how much money they need to save for major life events, such as going to college or retiring. In this example, Fred has placed $100 in a savings account that earns 8% interest compounded annually. Over the next year, Fred earns $8 in interest, which is just 8% of the $100 placed in the savings account. So far, we would say that if Fred invests $100 at 8%, the future value of that investment in 1 year is $108. One of the great things, however, about earning compound interest is that if you leave the money invested for a long time, during each future period, you earn interest on both the original investment as well as the interest that you earned in previous periods. For example, if after 1 year, Fred decides to continue his investment with $108 at 8% for another year, At the end of the second year, he will have $116.64 in his savings account. We can divide this balance into three components. First, there is the original $100 investment. Second, there is the $8 in interest that Fred earned during the first year. Third, there is another $8.64 in interest that Fred earns during the second year, which represents 8% of the $108 that Fred reinvested at the beginning of the second year. This pattern continues as long as Fred leaves the money invested earning 8%. To calculate the account balance after n years, Fred multiplies the original $100 times 1.08 raised to the nth power. That gives the future value of $100 invested at 8% for n years.
Okay, so that's that. All right, so here's the equation which he already showed you, and this is the important equation. You take the money you were just given and multiply 1 plus the interest rate shown as a decimal. Don't forget to the number of years. And here's how they do it, and there's a nice timeline here. So if you go through this math, the money's going to be in the bank for 5 years, one shot, right? So after 5 years, you'll have $927.42. And this is for 3% after 5 years. And of course, you can use a financial calculator, and they show you how to do that. And of course, this is the most important thing for you to know, how to use a spreadsheet, okay? An Excel spreadsheet. So I'm going to show you right now the future value of an Excel spreadsheet. Just give me 1 second and I will bring it up. So as you can see here, I brought up Microsoft Excel. Now watch this very carefully, because this will be good for your exams. You see this little guy right here, f of x? You see that? Well, if I click on that, and I hope it works. All right, I clicked on that, right? And now there's a lot of finance functions in here, and we're going to look for future value. So watch what I do. I can go in the search box and type FV. Whoops, hold on. I can type FV and click go. All right. And there it is, F of V, future value. Everyone see that? And here you put the rate, okay? Here you put the number of years in this case, and here you put the present value. Don't worry about payment for now. So if I put the rate, here's the way I do it. I would do 3, and I would put a percent, because it does the conversion automatically. Everyone see that? How it converted it to a decimal just by putting the percent? And then you just put like 5 for 5 years, and say you're given $800. So somebody hands you, and that goes in your pocket. So that's positive, right? Well, we can look at it another way. Hold on. We can look at this another way. You put it in the bank, so you took it out of your pocket, and you put it in an account. You don't have the use of it, so you make it a minus. Everyone see that? And here you'll have $927 and about 42 cents after 5 years. So this is important. Now when you click OK, it puts it right there. Now let's just talk about Microsoft Excel a little bit. And let me hold on. Let me cancel this and let's go here. Now you'll notice all the functions that they have, and one of the subcategories is financial. Everyone see that right there? Financial. So if I click on financial, look at all the functions, and if you'd like, you can study these. And as you know, there's a function going to be called present value, right? And then there's net present value, which we'll talk about. And present value is right here, right? And here's the rate to get the rate. And here's the payment if you wanted to know the payment. Okay. So there's a multitude of functions, and there's many functions for other things, date and time. And you should learn how to use these because they'll help you in your career if you know how to use these, all right? So I just wanted to make that point, okay? All right, so all right, so here's that. Now we're back to the textbook again. And you could kind of see what happens with money, how it grows. And obviously, the more interest you have in an account, the higher it grows. So this would be like the stock market over a long period of time, right? And this would be like some kind of savings account at Teachers Credit Union or something like that, right? Very low interest. You would accumulate very little, right? So, but you got to be careful. There's a lot more risk in the stock market. This could easily be minus 20%. So I want to let everybody know that. So they do a nice thing here about comparing compound interest and simple interest. And simple interest is when it doesn't compound, you just get the same amount every year, right? So you can clearly see here's simple interest. You get $50 a year with no compounding. And if you compare it to the compound interest, you can see there's a little bit more. You get an extra $2.50. Okay. And all right, so we'll highlight. That's important. So you can see in this column how it, and over here you can really see after 10 years how it adds up compared to simple interest, right? Everyone clear? You know, if you have any questions, you always can email me. And all right, so that's basically future value of a single amount, and then we'll do. I'll pick up on the next video to do present value of a single amount. I don't want to make these too long because you get distracted a little bit, and it's going to be the same concept when we do present value. You know, it'll be the same thing, except we're going to work backwards, right? Except we're going to work backwards in time. Alrighty. So make sure you practice with those Excel functions. They're really good to know about.